If you spent any time listening to people who are dealing with Lyme disease, long COVID, chronic fatigue syndrome, or other chronic inflammatory illnesses, you start to notice something strange. The diagnoses are different, the triggers are different, but the symptoms look remarkably similar. People report things like crushing fatigue, brain fog, poor exercise tolerance, sleep problems, muscle weakness, and even strange neurological symptoms, and a general sense that their body isn't functioning the way it used to. Now, at first glance, these conditions seem completely unrelated. Lyme disease is caused by a bacteria, long COVID is caused by a virus, chronic fatigue syndrome has multiple suspected causes, and autoimmune illness has its own mechanisms. So why do so many of these conditions feel so similar? Why do patients across these diagnoses describe almost the exact same experience? That's the question I want to explore today, because when you step back and look at the biology behind these conditions, a hidden pattern begins to emerge. And once you see that pattern, a lot of these confusing symptoms suddenly start to make sense. Let's begin with something simple. Your body runs on energy. Every cell in your body needs energy to perform its job. Your brain needs energy to think, your muscles need energy to move, your immune system needs energy to defend itself, your detox systems even need energy to clear toxins. Without energy, none of those processes function properly. And the energy you need is produced inside these tiny structures in your cells called mitochondria. Mitochondria convert oxygen and nutrients into ATP, which is your body's fuel source. You can think of it as the electricity that powers your cellular machinery. When mitochondria are working well, cells produce plenty of energy, but when they struggle, energy production falls. And when energy production falls across enough cells, symptoms start to appear. We're talking fatigue, brain fog, poor recovery, muscle weakness, reduced resilience to stress, and so many more. This is why mitochondrial dysfunction has become such a major topic in chronic illness research. But mitochondria themselves aren't the original problem. They're responding to something that's happening upstream. Now here's where this pattern starts to emerge. Many chronic illness sufferers share three common features. They're dealing with inflammation, circulatory disruption, and metabolic stress. So let's break those down. First is inflammation. Infections like Lyme disease trigger immune responses. Viral illnesses like COVID can activate long-lasting inflammatory pathways. And of course, autoimmune conditions involve persistent immune activation. Inflammation is the body's defense system, but when it becomes chronic, it starts to damage tissue. One of the places inflammation often affects early is the lining of the blood vessels. The lining is called endothelium, and the endothelium play a crucial role in regulating blood flow. And this brings us to our second factor. Circulation. Your circulatory system delivers oxygen and nutrients to every tissue in your body, but it does this through an incredibly delicate network called capillaries. These capillaries are where the oxygen actually leaves our bloodstream and enters the tissue. If those vessels become inflamed or their function becomes impaired, oxygen delivery begins to suffer. The oxygen may still be present in your bloodstream, but if it is not reaching the tissues efficiently and the tissues are receiving less oxygen, then mitochondria have less of the key ingredient they need to produce energy. That's when energy production begins to drop. And then there's a third factor, metabolic stress. So chronic inflammation increases oxidative stress inside our cells. Oxidative stress can damage mitochondrial components. It can disrupt enzymes involving energy metabolism, and over time, it can impair the body's ability to generate energy efficiently. So now we have three processes happening simultaneously. You have inflammation, you have circulatory disruption, and you have metabolic stress. Each of these factors on their own impair mitochondrial function, and when they happen together, energy production across the body begins to decline. Now think about what that means for the brain. Your brain is one of the most energy-hungry organs in your body. Even though it only represents 2% of your body weight, it consumes roughly 20% of the oxygen and the energy you use. This means the brain is extremely sensitive to any changes in energy availability. If oxygen drops even slightly or mitochondrial function slows down, the brain performance can change quickly. That's when people start beginning to feel symptoms like brain fog, memory problems, difficulty concentrating, mental fatigue, etc. In other words, the cognitive symptoms that many people feel with chronic illness, they're the same things that happen in the muscles. Muscles require a large amount of ATP to contract and recover. If the mitochondrial energy production falls, exercise tolerance drops. People just feel weak, recovery becomes incredibly slow. Even small physical activities can lead to disproportionate fatigue. And I remember this, getting on the floor with my children for just a short period of time, and I needed a nap, and I might need a nap for the rest of the day. This is one reason people with chronic fatigue syndrome often describe something called post-exertional malaise. After even minor exertion, their symptoms worsen dramatically because the energy system can't keep up with base demand. Now, this brings us back to the pattern. There's different triggers, similar symptoms, because the triggers often converge on the same biological bottleneck, which is energy production. Lyme disease may trigger inflammation and vascular dysfunction. Long COVID may disrupt microcirculation and immune signaling. Chronic inflammatory illnesses may create oxidative stress and mitochondrial strain, but in many cases, they all converge on the same downstream problem. Cells struggle to produce enough energy. Before I go further, I want to mention something that connects closely to this topic. If you're interested in how oxygen delivery and mitochondrial stimulation interact, we put together a guide called The Synergistic Power of EWOT and Red Light Therapy. That guide explains how improving oxygen availability and supporting mitochondrial activity together can influence cellular energy production. If you'd like to explore that concept further, there's a link below where you can download the guide. Now let's return to the bigger picture. When people are dealing with chronic illness, they often spend years chasing individual explanations. Could it be an infection? Is it mold? Might it be toxins or autoimmunity? And those questions can absolutely be important, but sometimes focusing only on the trigger can cause us to overlook the systems that are being affected downstream. The systems that determine whether the body has enough energy to repair itself. Because healing itself is an energy-intensive process. Your immune system needs energy to fight the infections. Your detox pathways need energy to eliminate toxins. Your tissue needs energy to repair all of the damage. Without adequate cellular energy, those recovery processes slow down dramatically. And that's one reason people can remain stuck in chronic illness for a long period of time. The body simply does not have the energy it needs to restore normal function. Now, there's another therapy that often comes up when people start exploring oxygen and cellular energy, and that's hyperbaric oxygen. Hyperbaric oxygen can dramatically increase the amount of oxygen dissolved in the bloodstream. And in certain medical situations, it can be extremely valuable. But when it comes to conditions like Lyme disease, there are some very important considerations people rarely talk about, because oxygen delivery and oxygen utilization are not the exact same thing. And if those two systems aren't properly aligned, hyperbaric oxygen may not behave the way people expect. There's a lot of nuance there, and it's something I've spent a great deal of time studying. So if you're interested in understanding when hyperbaric oxygen may help and when it may not behave the way people assume, I'd strongly encourage you to watch this next video. It's called Don't Do Hyperbaric Oxygen for Lyme Until You Hear This. And in it, we're gonna break down the different oxygen therapy modalities and how they can affect you and your Lyme disease. Thank you so much, and I'll see you there.